This is Honors Geometry. Note section 15.3, finding volume of pyramids and spheres. Volume of a pyramid. Well, just a reminder of some terms. This is a face. Where two faces come together is an edge. And where two edges come together, two or more, it's a vertex. If you were to find the volume of this pentagonal right prism, and then compare that to the volume of a pentagonal pyramid. First of all, what's the difference between a prism and a pyramid? A prism has two bases that are congruent to each other, and they're parallel to each other. I can't get this thing to do what I want to do. There we go. Anyhow, so if that's the base, this up here is another base. That's what makes a prism a prism. It's got two bases, they are parallel to each other and they're congruent. A pyramid has a base, and then there is an edge coming from each of the vertices that come together to a common vertex. There's a difference between a pyramid and a prism. So comparing these volumes, whatever volume you would get from a prism, the pyramid that has the same congruent base is going to have 1/3 of that volume. Very similar to us talking yesterday about a cone having 1/3 the volume of a cylinder if they had the same base. Well, let's see if we can do this. Let's get right into her. Determine the volume of the following. Well, the volume of a pyramid, which is what this is 1/3 the area of the base times the height. Remember that the height is perpendicular to the base. So this base is a rectangle. Specifically, this base is a square. It's base times height. It's 8 times 8. It's 64. So to find the volume, we're going to have 1/3 of 64 times the height. Height is 10. 64 times 10 is 640. That's not divisible by 3. So the exact volume of this pyramid is 640 divided by 3 cubic centimeters. Number 15, straightforward. Just want to point something out I didn't point out on the last one. If you take this face that you see here, there is a segment on that face that is perpendicular to the bottom edge of that. That is not the height of the pyramid. That is the height of that triangle. This triangle's height is determined by this segment that you see here, which apparently is 8. So to find the volume of this pyramid, it's 1/3 the area of the base times the height. The base is a rectangle, a parallelogram, if you will. Its base and height, which are 64. Now, I'd like to point this out once again. Some of these pictures, this one specifically, it's not real obvious what the shape is down here. Now, the directions would be better if they said, determine the volume of the following with rectangular bases. It's not how you spell rectangular. because if we don't know the rectangular bases, then we really can't find the volume or the area of this base. So I'm assuming that right now, just because I'm the one that made up these problems. And that should be in the directions. Same for this. This base here is a rectangle. You should not have to assume that. It should be obvious from the drawing, and it's not obvious, or from the directions, it also wasn't obvious. But I'm telling you what my intention was for this. And on the test, hopefully I'll do a better job. On the homework, hopefully I'll do a better job as well. So the base is 24, the height is 8. The height goes from the vertex to the base forming a perpendicular. It's the shortest distance from the vertex to the base. So a third of 24 is 6, and 6 times 8 is 48. I'm sorry, that's not true. A third of 24 is 8. 8 times 8 is 64. All right, how to find volume of a sphere? Well, it is 4/3 times pi times the radius cubed. It's very similar to pi r squared, the area of a circle, but it's pi r cubed because it's volume, and it's 4/3 of that. Find the volume. Well, this is straightforward. The volume of a sphere. You know how it's this? Now I know it's a sphere. That means it's shiny. That's going to be 4/3 times pi r cubed. R is 3. That's 4/3 times pi. 3 times 3 is 9, times 3 is 27. You can divide 3 into 27, it goes 9 times. 9 times 4, that's going to be 36. So this is 36 pi cubic centimeters is the volume of this sphere. Wow, now we're getting more interesting. I don't know why this says number 17. We have, to find the volume of this figure, we're going to have to take half the volume of a sphere and then add to that the volume of a cylinder. To find half the volume of a sphere, it's 1/2 times 4/3 times pi r cubed. R, in this case, is 6. Six cubed. Let me pull out my calculator for this. It is 216. So we got 1 times 4 is 4, 2 times 3 is 6. This is going to be 216. And then 216 we can divide. Oh. 216 we can divide by 6. It goes 36 times. 6 goes into itself once. Now we got 4 times 36. That's 144. So the volume of half of the sphere is 144 pi. Now we gotta find then we got to find the volume of the cylinder. So to find the volume of the cylinder, it's the base times the height. The base, which is a circle, is pi r squared. The height is 6. So it's going to be pi times r. r is the radius, that is 6 times 6. 6 times 6 times 6, we already said was 216. So the volume of this little fella is 216. So if we add 144 pi plus 216 pi, let's see, we're going to get 360, I believe. Let me just check real quick, because right now my confidence is shaken. 144 plus 216, 360. 360. 360. 360. Oh, it's 360. On the flip side. All right. Now, a term I didn't mention before, just because I didn't think of it. I mentioned this segment before. That's called the slant height, which is not the height of this pyramid. In order to find the volume of this pyramid, we need to take 1/3 of the area of the base times the height. Now the base, which is a rectangle, 6 by 6. Once again, we're assuming that it's a rectangle. The height, we don't know what the height is. So can we figure it out? Well, if you look, if this whole thing down here is 6, and this height is perpendicular to this, it's going to cut this in half, which is going to make x 3. If the slant height is 5, that means this figure here is a right triangle. Not just any right triangle, it's a 3, 4, 5. It's a Pythagorean triple. With the height being 4, a third of 36 is 12. 12 times 4 is 48. Our unis are cubic centimeters. Number 19. We have a lateral edge is 13. Let's figure out what this height is, and then we can find this volume. So if the lateral edge is 13, right now let's focus on this triangle that you see here. That is a Pythagorean triple. It's a 12, 5, 12, 13 right triangle, Pythagorean triple. Now, that doesn't tell us what the height is, but it gets us closer. Because if we move this 10, which is this distance here, this height is going to cut that in half. That's going to make this 5. So now, looking at this green triangle, we have the hypotenuse is 12, a leg is 5, we don't know the other leg. This is not a 5, 12, 13, because that would make a leg 13, which would be bigger than the hypotenuse, which is impossible. So we're going to have the Pythagorean theorem, x squared plus y squared is r squared. X is 5, y is h, and r is 12. That's 25 plus h squared plus 144. It's going to make h squared 119, which is going to make h plus or minus the square root of 119. I'm talking about a distance, so we're going to assume that that's positive. So to find the volume of this pyramid, it's 1/3 the area of the base times the height. The base looks like it's 10 by 10. That would be 100. The height we just figured out is the square root of 119. So this cannot be simplified well. I'm just going to write it like this mess. You could also write it like this mess if you wanted. Anyhow, the unis here are cubic centimeters. Number 20. So 20 is a little different. This time we know the height. I think that, yeah, the 10 is the height, and it shows that. It says h is the height. So the volume of a pyramid, once again, is a third of the area of the base times the height. We don't know the base, but we do know the height is 10. So once again, to make it clear, the base is this triangle, so right triangle. We know the hypotenuse is 13 and the leg is 5. It's a Pythagorean triple. It's going to make this one 12. So 5, 12, 13. If you don't recognize it's Pythagorean triple, no big deal. Just use the Pythagorean theorem. You'll also find that it's 12. So that base of the triangle is 1/2 base times height. 5 times 12 is 60. Half of 60 is 30. Third of 30 is 10. 10 times 10 is 100. It's a lot of hundays. Well, it's 1, so I guess it's not a lot. Number 21. Well, boy, we got a lot of work to do for this one. I don't know if you recognize it, but I do. To find the volume of this pyramid, the concept's simple. We take a third of the area of the base times the height. And we know what the height is. It's 18. Clearly shows that the height here is 18. Well, to find the area of this base, it's kind of a lot of work. We got to take half of the perimeter times the apothem. We are assuming the picture is drawn to scale. Once again, I hope the homework is drawn more accurate, where you're given and told specifically what kind of shape that base is, or you're shown it. Because right now, these ones aren't doing a good job. So I'm telling you this problem was, the intent was it was a regular polygon. So the perimeter of this is going to be 36 because 6 times 6 is 36. To find the length of the apothem, we got some work to do. Boy, do we have some work to do. We would want to find the measure of a central angle. It's 360 divided by the number of sides. There are 6 sides, so it's 60 degrees. So this angle right here would be 60. If you remember, if you draw the apothem, that's going to cut that central angle in half. Half of that's 30. It's going to make that a 30, 60, 90. What I'm drawing right now would be this triangle right here, this red triangle. The apothem also cuts the opposite side in half. Half of 6 is 3. This is the 6. Cut in half, we get 3. Opposite 30 is 3. Opposite 60 is that times the square root of 3, so it's 3 squares of 3. Guess what's not going to go away, boys and girls? Global warming. Guess what else isn't going to go away? Paying your taxes. Guess what else isn't going to go away? Special right triangles of 30, 60, 90. So this apothem is 3 square roots of 3. Half of 36 is 18. 18 times 3 is 54. So the area of this space is 54 square roots of 3. Third of 54 is 18. Eighteen times 18 is 324. And this was centimeters, so it's cubic centimeters. Let me just make sure that that's right. Yep, that is correct. Number 22, be the last one. Find the volume of the can, not including the 2 tennis balls. So, to do this, to find the volume of the can, we're going to take the volume of the cylinder and subtract 2 times the volume of one of these spheres. Makes sense? Let me hope so. To find the volume of a cylinder, it's the base times the height. The base is a circle whose area is pi r squared. Picture shows that the radius is 9. Picture shows that the height is 26. Such nice, easy numbers to work with, am I right? We get 81 pi times 26, which is 2,106 pi. That's the volume of the cylinder if there were no balls in it. But it's got balls. It's got 2 tennis balls. To find the volume of one of the spheres, it's going to be 4/3 pi r cubed. The radius is 6. We said earlier that 6 cubed is 216. 3 goes into 216 17 times. 72 times 4 is 288 pi cubic centimeters. So to finish this, volume of the can, we take the volume of the cylinder, 2,106 pi, minus 2 times the volume of one of those balls. That's going to be 2,106 pi minus 576 pi. We're going to get 1,530 pi cubic centimeters. We've been using a lot of the metric system. What are we, in Canada? Alrighty. Thank you. Thanks for paying attention.